Alright, something a little bit easier for this appendix lesson. Polynomials, there is some factoring involved, but mostly adding, subtracting, and multiplying polynomials. So let's take a look at this. If I had something like 5x squared plus 3x minus 8, and I was going to add to that 3x squared minus 9x plus 12. Just for instance, I'm going to combine my like terms. Now if I had a number out here, I would go ahead and distribute that number or whatever that thing is before I add and subtract, but let's just say that there's not. I can line these up, so if I wanted to, I could go ahead and line the 3x squared up with the x terms up and the constant term up, and then I can combine. And this is a good method to stay organized, though you don't need to do it. And we combine our like terms, and this is our answer actually. Pretty good. Now, note on how to write these. We want to write them in order alphabetical of our variables, so I only have one variable, x. And then I want the exponent to decrease. So x squared first, then x, and then the constant term last. If I had two variables, for instance, say I had 4x squared plus 2xy plus 3y squared, something like that. This is actually in the right order. If I had two variables, then I want the one that's alphabetically first to come first with its highest power, and then the one that's alphabetically last to actually its highest power to be at the end. And then as they share powers, the shared the terms that have both of them go in the middle. And notice that x has decreased its power by 1, and we could say, well, y is to the 0 right here, and y has increased its power by 1. And then x continues to decrease its power while y continues to increase its. So as one's exponents decrease, the other's exponents increase. So that's writing it in standard form. This polynomial here is degree 2. And the reason it's degree 2 is because I take a look at the term with with all the exponents, I add them up, and that gives me the degree. Now this is only degree 2, but if I had a term like this, and let's say that's a 2 right there, not a z, then the degree of this term is actually 10. That's its degree. Its degree is the sum of the exponents, and that's a 1 right there. So 7 plus 2 plus 3, or 7 plus 2 plus 1 is 10. So the degree of that term is 10. The number in front is the coefficient. Okay, so that's adding, and we will want to write all our answers in standard form, it's called. Let's say I had something like this. That should be squared right there. Alright, let's say I'm subtracting these. Again, I can line up my terms, but I want to be careful of this negative right here. I want to make sure I switch all the signs that are in there. So I'm actually subtracting 5x cubed. It was positive, now it's negative. I would distribute that negative to every term. This is a negative 3x. I want to make sure I line that up with the actual x term. I don't have an x squared term in this one. And then a negative 12 is a plus 12. And then I go ahead and I can combine these and get negative 3x cubed. That's going to come down. So 4x squared minus 8x plus 21. That gives me my answer there. Well, including the 1 right there, 21. Alright, now multiplying. Let's say I had 3x squared y, and I'm going to multiply that into, say, something like no y. I'm going to go ahead and distribute this to every term. That's very important to make sure we get it to all the terms. We multiply the coefficients in front, so we get a 15. X squared times x squared is x to the 4th. Now there is a y here, there is not there. So y, I keep that one. Plus 3 times 3 is 9. X squared times x is x to the third. See, that exponent's a 1 if it's not written. That exponent's a 1 if it's not written. 1. And then y times y will give me y squared. Plus, and then I just have the coefficient there, so it's a constant term. So I have 21x squared y. And that's multiplying that. Now if I had two things, 3x plus 5, let's say, times 2x minus 7. Let's say I'm multiplying these two things together. Now I'm just going to jump right to the trick, but I will quickly explain where it's coming from. What I'm really doing is I'm taking this entire thing, all of it, and distributing it to this term, and then taking all of it and distributing to this term. So essentially what I'm getting is 2x times 3x plus 5 minus 7 times 3x plus 5. And then I end up distributing this to each of those, and this negative 7 to each of those. Now there is a trick, and I'm going to show you the trick to make that not take such a long time. And that trick, really, if you just stick with the pattern here, I'm going to end up taking this and multiplying it times both of those. And I'll take this and multiply it times both of those and combine whatever terms happen to be like. So 3x times 2x is 6x squared. And then 3x times this other thing here is negative 21x. 5 times 2x is 10x. And then 5 times negative 7 is negative 35. And then I'm going to go ahead and combine my like terms. These are like, so I get 6x squared minus 11x minus 35. And that gives me my answer there for multiplying those. Factoring. The first step, now this is very, very important. We tend to forget this step, is to factor out the common monomial. We always want to try to do that first before jumping to what I'm about to showing you. So if I have 3x squared plus 8x, and I'm factoring this. Now this is simplified. Factoring is not the same thing as simplifying. But if I'm going to factor this, then what I'm going to do is look what's common between both of these. And in x, it happens to be common to all of them, so I can factor out an x right at the beginning. That leaves a 3x plus 8. And I can quickly check and make sure, by just kind of thinking in my head here, if I multiply this, do I get this original back? And I do. Let's say I had x squared plus 4x minus 5, and I was going to factor this. Now, as I look, the first step is to factor out the common monomial. Well, I look at all these terms, and there's nothing common in all of them. So now I'm going to jump to the next step, which is factor the binomial. So I'm thinking of two things that multiply to give me an x squared. Well, in this case, there's only one possibility. X times x gives me x squared. Now, I need to think of factors of 5 whose sum or difference could possibly be a 4. So I'm going to say, well, I only have one possibility here, a 5 and a 1, because 1 times 5 is 5. But I know that this is going to be positive right here, so I'm thinking a plus 5 and a minus 1. Now, I need to check to make sure that I've done this right. It'd be a shame to be doing a complicated pre-calculus problem and not factor correctly. So I want to make sure I've done this right. So I do a quick test. X times x. Yep, I got my x squared. Negative 1 times 5. Do I get my negative 5? Yes, I do. So I have that. Now, here's where we usually mess up, is the middle. Do I get this 4x? And there's an easy way to check that. Check that. Negative x. Check those two. 5x combined. 4x. Yes. So that worked out just fine. Alright, so this is that factored. Now, well, let's say that I actually had this. Most students take a look at this and they freak out, first of all. And then the next thing they do is they jump right to this type of factoring where I write down my two things here. And that's not right. I shouldn't jump to that right away. What I should do is this first thing. Factor out the common monomial. What's common in all of these? Well, I take a look at my coefficients and I see I could divide them all by 5. And I take a look at my variables and I see, well, there's at least one x in each of them, so I can factor out an x. And that's going to leave me with, what do I multiply by to get this? That's x squared. And 4x. And here, minus 5. See, if I distribute this, I get this back. Well, this is identical to this one, so I factor this, and then this is my answer. I have factored out the 5x. Now, occasionally, a student will be at this step, and they will jump right to here, and they'll get something like a 5x squared minus a 5x. And this is still wrong because there's still some factoring that could be done. So we always wanted to factor out that common monomial first. Let's say that I want to factor something like this. Alright, now I see that I don't have a middle term and there's nothing common in all of them, so I'm going to try to do this. And two things that multiply to give me 5 or 25 or 5x. See, 5x times 5x, 25. And 36, well, I could get 6 times 6. Now, I don't have a middle x term, so one of these is positive and one of them is negatives. And if I do my quick check, 5 times 5, 25, 6 times 6 gives me my negative 6 times 6 gives me my negative 36. And then I check here, negative 30. Check here, plus 30. And yeah, that's 0, because I don't have a middle term, so that's fine. Alright, let's take a look at some examples of what you might have to do. These are simply combining, simplifying, so I can write this vertically if I would like. You don't have to. So just move that all down there by like term. So I get 4x squared plus 2x plus 4. And if I were factoring, I don't have to factor. I'm not told to factor. In fact, this would be wrong. But I could factor a 2x. I could factor out a 2. Now, I don't want that though, because the directions say simplify. That's factored. I want it expanded like this. Alright, this one's subtracting. I distribute that negative, so I get negative x cubed, negative 12x, and then plus 3. Now my plus 3, now I see that this, I did not line this up properly. So I've got to line up my like terms. That's an x squared, so minus 12x. And then I have a plus 3 hanging out here. There's no like term there. So 4 minus 1. That's going to copy down, and, well, not copy down here. We actually subtracted that, and then there we go. Alright, now we're multiplying, expanding, and distribute this to all the terms. So I get 2x cubed minus 2x squared plus 6x, and done right there. See why it wouldn't make sense to factor this. I just go right back up to there. So don't want that. It doesn't matter that this is at the beginning, at the end. I can distribute it this way. I can go the other way too, or I could put it in front if I prefer. 10x minus 5x squared minus 15x cubed. This is not in standard form, so I will write it in standard form by moving around my terms. Notice the negative goes with the number that it's in front of. And that's my answer there. Alright, now we are multiplying. So this times both of those. And this times both of those. And I get x squared plus 3x minus 10. Same thing here. This times both of those. Notice these are only different by sign. That's a perfect square plus 3xy, and we'll see that the middle terms will end up going away. Notice that even though it's y times this, I still write my variables in alphabetical order. So those end up canceling. And we get 9x squared minus y squared. This right here has a name. This is the difference of perfect squares. Alright, now we are very tempted to distribute exponents. You cannot distribute a power. That is not how that works. You might think, well, Mr. Kane, you had this and you had that and then you multiplied. This was a power to a power case. So yeah, in that case, but I'm not distributing it. I'm using the rules of exponents, power to a power. Notice there's no plus or minus sign here. This is all one thing. This is not one thing. This is two things, or we could have more than two things, but they're separated by a plus sign or minus sign. So I do not try to distribute this and get 3 squared, x squared, 4 squared, y squared. I don't do that. A power means something multiplied by itself. So I'm going to want to write it out like this, and then now I can go ahead and distribute. And then this. Combine my like terms. And this one, actually, and this is our answer, this also has a special name. So like here, difference of two perfect squares. Here, notice how these were the same. Our answer here also has a special name. This is called a perfect square trinomial. Why trinomial? Because it has 3 terms. I can multiply this out and notice again different and only in sign there. So this times both of those. And this times both of those. And again, I'm writing my variables in alphabetical order. And then these two middle terms end up canceling. And this is a difference of perfect squares. Now I have a cube here. That's going to take a while. Write it out. Well, where do I start here? It really doesn't matter. So I'll do this first. I get 4x squared minus 6x, and then multiply here. Now, I see students do this all the time. This is wrong. Why is this wrong? Because technically what we're saying here is 9 times these two. What we mean is all of this, it needs to be in parentheses, times this, because this is all a multiplication problem. So I can go ahead and simplify in there. See, I need those parentheses, they're important. And I'm actually going to, this is an x squared, sorry. This times both of those, so I get 8x cubed minus 12x squared. This times both of those, so minus 24x squared minus 36x. And then this times both of those. We could combine those, so let's go ahead and do that right now. 52x minus 27. Hopefully I didn't make a mistake in all that adding in my head. Alright. Oh no, radicals. Yes. Get used to, in pre-calc, topics overlapping a lot more than you used to. So we are talking about polynomials and multiplying, adding, subtracting, but radicals are fair game. So we just do the same thing. These have the same index, so root x times root x is root x squared, which is x, so I get an x. And then minus root xy. Then this multiplies. So root y times root x, so plus root xy. And then root y times negative root y, so that's root y, which is negative root y squared, which is negative y. So minus y. And then these two terms cancel, so I get x minus y. No big deal. Factoring. Alright, well, let's just practice this. Be handy if you see if you can. Now I check to see if there's a common monomial, but see if you can get ahead, factor them before I do. So my first thing here is a y. So y times y squared. I need an 8 here. And somehow with my factors of 16, well, I have 1 and 16. If I add and subtract those, I don't get an 8. I have 2 and 8. If I add them, I get 10. If I subtract them, I get 6, so that's not going to work. 4 and 4. 4 plus 4 is 8. Okay, so 4. And this is plus. That tells me that these two signs are the same. And they could be the same as in both negative. But then if I check, I get negative 4, minus 4. That's not positive 8. So these are plus. And then I do my check. 4y, check 4y, combine 8y. And this check is going to work as long as I have made sure that I get this sign correct by 4 times 4 and this correct by y times y. Alright, now this lead coefficient here is not a 1. So this is tricky. I have two possibilities, essentially. I could have 2x times 2x, or I could have 4x times x. If I multiply those, I get my 4. And if I multiply these, I get my 4. In general, you're going to want to start with the factors that are closest together, and if you can't get it to work, well, then you expand down to a situation like this. I only have one factor of 1, and that's 1. This is plus, so that tells me that these two are the same. And since this is a minus, well, I know that I would have to have a minus right there, so let's do our check. So negative 1 times negative 1 is positive 1, and 2 times 2 is 4. So let's check this. Negative 2x. Negative 2x is indeed negative 4x, so that checks. That's correct. Alright. Check, always check. Common monomial, not 1 in this case. So x times x. Factors of 14, well, we have 1 and 14. We have 2 and 7. Which of these can get us a 9? Well, the 2 and 7. So 2, 7, plus and plus. Alright, so this is a negative here, so that tells me that when I get to this step, that one of these is plus, and one of these is negative. See, when this is a plus right here, see, that's a plus. I either have a minus minus in the middle, or I have plus plus. When this is a minus, one of them's a plus and one of them's a minus. Now, this is an x, so x squared, so I have an x times x is x squared. Now, I want factors of 24. That could give me a 5 here, a negative 5. So I have 1 and 24, well, that's not going to get anywhere close. I have 2 and 12. I have 3 and 8. Subtract those. 3 minus 8. Yeah, so 3, 8. So the 8's going with the negative because that's a negative right there. Alright, this one. Both of these are going to be the harder case. So we're going to start. We do have a 1 and 14. We could have a 2 and 7. Let's say we have 2x and 7x. I need a 33 here. So my factors of 5 are 1 and 5. Well, if I put the 5 here and the 1 here, this is where the quick check helps. 2 and 35. Okay, so that 2 and 35, when I multiply this, 2x, 35x, could I combine those to get 33? Yeah, if this one were positive and this one were negative, that gives me a negative 33x. So I'm using this check to help me know, because this where this sign's going to go, this is negative. So one of these is negative, one of these is positive. I need that negative, this 35 to be negative. And I multiply these two numbers here to get that 35. So this one's going to need to be a negative, and this one's going to need to be the positive. And then that'll work out. So 12 right here, I have 1 and 12, I have 2 and 6, and I have 3 and 4. And when we're factoring, we're going to start with the two factors that are closest together, because they are the most likely to be successful. I have a 15 here, and my factors of 15 are 1 and 15, and 3 and 5. And again, we're going to start with the factors closest together. So let's say I go with 3 and 5, and I just test it right there. Do my quick check. 15, 12. So I have 12x, 15x. It doesn't look like it can add and subtract those in any combination to get 11. But that doesn't mean the 3 and 5 is wrong. Maybe I just put them in the wrong spot. So maybe it's 5 and 3 like this. And this is much more reasonable actually, because even if it turns out to be wrong, with the 3 right here, which is what I had before, there would be a common thing that I could factor out, which would tell me I could have factored out something common up here, which I can't. So that's why I know that's probably not the case. So if I do my quick check, 20x and 9x, well, I could, if I add those, I get 29, but what if this one's plus and this one's minus? Well, then 11x, which is what I want. So I need this 20 to be positive, so plus right here, and this 9 to be negative, so when I multiply those, negative. Now I want to make sure 5 times negative 3, yep, that's negative 15, so that's okay. Alright, so at this point, you are ready for your second summer assignment. So let's see, what is that assignment? I forget what it is. Let me look. It is going to be Appendix 2. You're going to do exercises 2 to 52 even and 60 to 68 even. You'll notice that we're skipping the factoring the perfect cubes. And that's because later in the year we will learn to do it a different way, so we won't bother with the method that they show in the appendix. Oh, and this is Appendix 2. So whichever page number that happens to be, I'll look it up right now. That happens to be page number, of course it's not going to show me, 789. So this is page 789.